Hello guys, I am Sanskar Raut, a second year student at VIT Pune. So starting to the second part of the DBMS, introduction to the DBMS. So now we will cover the various tiers of DBMS, types of DBMS and others. So let's start. So moving to the first point, DBMS architecture. There are three types of DBMS architecture. One tier architecture, two tier architecture and three tier architecture. And these three architectures based on three different databases which are linked to each other. In the one tier architecture, only one database is there which have all the information. Like if we read the point, in one tier database, the database is directly available to the user, and the user can directly sit on the DBMS and use it. Also, the client, server, and all are present in the same database or on the same machine. For example, the offline SQL we learn in our labs or etc. It is an example of a one tier architecture. Sometimes one-tier architecture can also be referred as centralized system with single user system. As you can see in this slide, there is a centralized computer system having two disks, one printer, tape drive, which are all connected using system bus. It is a one-tier example of one-tier architecture of DBMS. So moving to the two-tier architecture. In the two-tier architecture, there are two databases, one client and they work on client server mode. The application of client end directly communicates with the database on the server side, and the communications are handled by APIs or application protocol interface like ODBC, JDBC, etc., and are used for the interaction. The server side is responsible for providing query processing and transaction management functionalities, whereas on the client side, the user interface and application program run, and it sends a request to the server for fetching the data. The application on the client side establishes a connection with the server side in order to communicate the DBMS and in order to give and take the data. In the main advantage of this type of system is that the maintenance and understanding are easier and it is compatible with the existing systems. However, there is a problem like this model gives issue when large number of users are accessing a single server. As if I have a server set up for 1,000 clients, but if 2,000 or 3,000 clients try to use the server at the same time, there is a problem and the server will crash. So it is the main problem, the two-tier architecture, where now the three-tier architecture comes into picture. So this is the three-tier architecture. In this type, there is another layer between the client and the server, and the client does not directly communicate with the server. It acts as a mediator. And because of the mediator, the first initial problem of the server crashing is solved as the mediator manages all the requests and send it to the server. So basically here, the client doesn't directly communicate with the server, but communicate with an application server, which further communicates with the database server. And the query processing happens, and the transaction management takes place. This intermediate layer acts as a medium for exchange of partially processed data between server and client. And this type of architecture is used in case of large web applications like any application we use in our day-to-day life, like Google, Facebook, Amazon, etc. and any application you can remember. So moving to the advantages of three-tier architecture. First is enhanced scalability. Due to the distributed deployment of application servers, now individual connections need not to be made between client and server. Means we can set up various servers at various places and application server can manage the requests. Second is data integrity is maintained. Since there is a middle layer between server client and server, data security is there and data corruption is avoided. Third, and the most important point, security is improved. As the client doesn't communicate directly with the server, data is secure in the server and is less vulnerable to the hackers or to the bad people. Moving next, server system architectures. Server systems can be broadly categorized as transaction servers and data servers. Transaction server systems, also called query server system, provide an interface to which client can send requests to perform an action, in response to which they execute the action and send back results to the client. For example, these servers were the application servers in the three-tier system, which we are also calling the middle system. Usually, client machines ship transactions to the server system, those where transactions are executed and results are shipped back to the client. As, for example, in the example of a login, for example, Google login. In the Google login, we open a website which is on the transaction server Firebase, and it handles our transaction and then returns our data to the application. And the requests may be specified by using SQL or through specialized application program interface. So, continuing to the server system architecture. Second type of server system architecture is data server system, which allows client to interact with the server by making requests to read or update the data. Basically, this server or this architecture basically stores the data, like the attendance monitoring or of any college. The data is stored and the application works or interacts with the data server system, and it updates the data or increases the attendance as the new lectures or tutorials happen in the college. Second example is the file servers provide file system interface where clients can create, update, read, or delete files like Google Drive. It is also a data servers architecture, which is a server system architecture. So moving ahead, classification of database management systems. So there are several criteria used to classify DBMS, like classification based on data model, relational data model, and object-oriented data model. Classification based on username, single user system, multi-user system, or classification based on database distribution, which is centralized distributed. And in the distributed, also there are two types, homogeneous and heterogeneous. So let's look forward. What are these different types of database management systems? So basically, speaking of the single user and multi-user, single user system is nothing but a system which is based on a single computer, and multi-user system uses server which is connected to multiple computers. A single user system is an, for example, a SQL server based on a single system, and multi-user system we can use any example or any web server. Secondly, a centralized system. Various computers are connected to a single system, which is known as centralized system. As you can see in the first picture. And in the second picture, there are various satellite systems which are finally connected to a computer network. This is called a distributed system, where the main computer network handles 4 5 other networks, and those networks handles the computers. Hence, the workload is distributed among various systems. So, why is database design important? So, why is database design important? Database design provides the blueprint of how the data is going to be stored in a system. A proper design of the database highly affects the overall performance of any application. As if the database is not designed perfectly, the server or the request will be clashed and there will be server crash happen. So there are various designing principles defined for a database to give clear idea of behavior of any application and how the requests are processed. Another instance to emphasize database design is the proper database design meets all the requirements of users. As if we are making attendance system, the attendance of every student should be kept different. Whereas we are keeping record of any request of hotels or the food items, there the instead of managing a data of single order, there the data is managed as per the single food item, and data is kept. Lastly, the processing time of the application is greatly reduced if the design is good. So, database design process. A database design generally defined as collection of tasks or processes that enhance the design, development, implementation, and maintenance of enterprise data management system. It simply means mapping of conceptual model to implementation model. As firstly, we make a conceptual model or a ER diagram, we say, of the database, of how will the database look like and how will the data store, and then we implement it. And whole thing is done by database design process. So there are 6 phases in the database design process. First is taking the requirements and analyzing them. Second is conceptual database or ER. Third is which choice of DBMS or which type of system we use, SQL, MongoDB, etc. Fourth is data model mapping or logical database design, where we create the main database. Fifth is physical database design. And sixth is database system implementation and tuning. So here you can see the whole working or workflow of the database design process, where first is requirement specification, then database design is done, and application planning. These both steps are done together as so we make an application and we make a database both continuously, as we make a database as per the requirement of the application, and we make the application as per the database is design. Next is after database design is done, application design is done as as per the design of database. Next, the database implementation and application implementation. And then both database and application are both linked together and testing is happening. And after that, when the testing, the deployment is done, product is out and maintenance. So phases of database design. First, we have seen the 6 phases. So defining each phase. The first is requirements collection and analysis. It makes identifying users, interacting with users to gather requirements and time But this process is very time consuming, but it is very important as the database design should be as per the user or as per the requirement. Second is conceptual database design. Produce a conceptual schema of the database that is independent of specific DBMs. It involves two parallel activities: conceptual schema design, transaction and application design. The detailed plan for implementing and managing database. So moving to the approaches of conceptual schema design. There are two approaches. One is centralized scheme design approach, also known as one-shot approach, or second is view integration approach. In the centralized scheme design approach, requirements of different applications are reusable are merged into a single set of requirements and single schema is designed. It is time consuming and it is places to burden on database, but to reconcile conflicts. Next, view integration approach. Here, the schema is designed for each user group or application. These schemas are then merged into a global conceptual schema during the view integration phase. It is more practical as the database is different for each concept, and if we try to merge all in together, it is a very hectic job and it is complex. So designing it differently is very easy and very practical. Second, strategies for schema design. First is top-down strategy. A strategy with a schema containing high-level abstraction and then apply successive top-down refinements. As for example, of speaking in the database of a college, there is a faculty which teaches and a course database faculty and both are linked by a teachers. Next, faculty teaches courses and faculty offers seminars. And like this, the database comes ahead and elaborates itself. So other strategy is inside-out strategy, where we start with central set of concepts and then spread out outward by considering new concepts in the vicinity of existing ones. And third is mixed strategy, where we use top-down strategy and inside-out strategy together. So phases of continuing the phases of database design, many factors consider the choice of DBMS. So DBMS, choice of DBMS is important as there are various types of DBMS, relational, object oriented, alone, and different storage types. They have different storage types and architecture options. So we have to make a choice of DBMS as per our requirement, as per the need of the user. So moving ahead, phases of database design. The next is data model mapping, which is also phase. During this phase, which is also known as logical database design, we map or transform the conceptual schema from high-level data model used in phase 2 into the data model of a chosen database. We can start this phase after choosing specific type of DBMS. For example, if we decide to use some relational DBMS, but we have not yet decided on which particular one, we call the latter system independent but data model dependent logical design. Next is physical database design, which is phase 5. In this phase, we design the specification of the stored database in terms of physical storage structures, record placement, and indexes. So moving ahead, database system implementation and tuning. It is the final phase. And during this phase, the database and application programs are implemented, tested, and eventually deployed for a service. It is the last and final phase where our planning from phase 1 to phase 6 are implemented. Various transition applications are tested individually and then consumption with each and then they are joined together. This typically reveals opportunity for physical design changes, data indexing, and reorganization. As when we implement or when we finally deploy the database, we get certain problems and then we come to again sort out the problem at the physical layer, at the logical layer, and database, which is also known as database tuning. Tuning is an ongoing activity, a part of system maintenance that continues for a life cycle of database as long as the database and application keep evolving and performing. So this is the last slide and the phases of database design. So here we end our phase session 2 of Introduction to DBMS.